Okay, there we go.
All right. Can you tell me your name, please?
My name is Bill Vaughn.
And what do you do?
I'm a neurophysiologist, assistant professor at Wake Forest University School of Medicine.
All right. Thank you very much, Mr. Vaughn. And our first question, how long have you worked in the medical field?
Okay, well, I'm a scientist. I don't exactly work in the medical field, but I work at a medical school, and I've been in the field for 25 years or so.
Okay. And what do you think has changed the most in the past 10 years in relation to what you do?
There's a big advance in our field. What I do is I study the behavior of nerve cells in the brain. And the biggest advance that's happened in the last 5 to 10 years is the capacity with which we can study those cells. So what we do is we nudge little pieces, little antenna close to the body of a cell, and we record the behavior of those cells when they're responding to various stimuli in the world. And what we've been able to do lately is to have the ability to put more of those probes in the brain and study the brain as a sequence of circuits, passing activity from one place in the brain to the next. And so we can study the path at which that information is transferred.
All right. And how often do you have to receive training for various medicines and equipment?
Every so often we have to have veterinary training because I do work with animals. So I don't know, maybe every year or so I have to take exams that qualify me to be able to do surgeries and various procedures.
Okay. And what is the newest equipment that you have been trained on?
Well, I haven't been trained on it, but I'm looking to start an experiment that uses magnetic electroencephalography.
Okay.
It's abbreviated MEG. And what that machine does is it picks up local magnetic fields inside of the brain. So we can do these studies on humans and ask questions about where various sources of activity are happening as we present stimuli into the world and investigate the way that information is traced within various places in the brain.
All right. And the last question, do you think there could be improvements to the equipment? And if so, how?
That's a good question. These kinds of things are being improved all the time, and the MEG is one of the most advanced forms of physiological analysis that is done in humans. There's the other thing that you probably have heard about is magnetic resonance imaging, which is abbreviated MRI, and so a lot of people are using fMRI, which is functional magnetic resonance. And in that, you are investigating the activity of cells inside of the brain in conjunction with various tasks that the person is performing while he's in a scanner. But what we're doing here is we're actually looking at, with the MEG, is we'll be looking at individual fields while the subject is performing a task, and we can get very good spatial resolution with that kind of technique. And it's an advance on the fMRI, which has good spatial resolution but poor temporal resolution, which is to say when things happen in the brain. So MEG offers the ability to not only have a good idea of where things are happening, but also when things are happening in relation to the stimulus, because that's what we do, is we study the way in which the brain puts together the world from little bits of information that are in the environment.
All right. Well, thank you, Mr. Vaughn, for answering our questions.
Okay.
And I hope you continue to do well in your career.
Thank you very much.